This video is going to cover Trig Notes 2.1 or Pre-Calc Notes 5.1. The topic is using fundamental trig identities. So at the very beginning of this chapter, I gave you a trig formula sheet. It's going to be very, very helpful. What I have over here is just a portion of that formula sheet, and you don't have this on your notes, so you're going to want to have your formula sheet out and looking at these sections. These are going to help us to be able to find these 6 trig identities that we're asked to find for this problem. So as we take a look at this, we're asked, or we're given the fact that the tangent is 2, so I know that the tangent is positive, and the sine is less than 0, so that means that the sine is negative. So thinking about this in terms of where sine, cosine, tangent are positive and negative, tangent's positive here and here, so that's quadrants 1 or 3. Sine, on the other hand, is negative, where the y values are negative. That's here and here. So that would be 3 and 4. So the first thing we have to figure out is that our problem is going to be in the quadrant, the third quadrant. And that's going to be key that we understand where that's happening, because to use these identities we need to know whether our final answers will be positive or negative. And so what I want you to do next is go through and list out whether all of these answers should be positive or negative. Well, we already know that the tangent is positive and that the sine is negative, just from this information here. Well, what I know is if the tangent is positive, then the cotangent, which are just reciprocal identities of each other, would also be positive. And with that being said, if the tangent is 2, then the cotangent is just the reciprocal, 1/2. And I'm getting that from this right here. That cotangent is 1 over the tangent, so 1 over this would be 1/2, or just the reciprocal. Likewise, if the sine is negative, then the cosecant is also negative. Last thing I have to figure out is, what about my cosine and secant? Well, let's go back over here in the third quadrant. Cosine are the x values. Well, these x values are negative here, so therefore the cosine are both, and secant are both going to be negative. So it's going to be really important that you do this before you start your problem, because you'll tend to have answers down here and you'll forget whether your answer should be positive or negative. So if we think about following this kind of in some sort of logical order, so it's useful for you to go back and use your notes to help you look at the steps. First thing we did is discuss what quadrant we're in, and then the second thing we did was we figured out, once we're in that quadrant, whether things are positive and negative. Okay, so now, given the fact that I only know tangent and cotangent, I need to find these 4 identities. So if I go over here, let's try to pick a identity that has a tangent in it and one of these other identities. Right away, I'm drawn to this one right here. 1 plus the tangent of x squared is the tangent squared of x is equal to the secant squared. So I'm going to use that one. Because here's what I know. I know that if I do 1 plus the tangent, which is 2, and then I square that, I'll be able to solve that for the secant squared. So I can find the secant next just by using this identity. So part of what the process is for this for this chapter is using this kind of as a clue or as a decoder to help you find something else. If you've ever done those decoders off the back of a cereal box, where A stands for, a star, and B stands for a smiley face, that's essentially what this is you're trying to come up with some other identities that are the same as what secant is, so you can actually find it. In this case, I'm using the fact that 1 plus tangent squared is the same as secant, so if I do 1 plus the tangent squared, I'll get the secant squared, and then I can get my answer that way. So that would mean this is 5. And to solve for the secant, I'd have to get rid of the squared. So the square root of 5 is what the secant is. Now notice that algebraically I'm going to get a positive answer, but I know because of the third quadrant the secant should be negative, and that's where this is going to be very crucial. If I didn't take the time to do this, I would have wrote that down as a positive square root of 5, and I would have got this wrong. So the next thing I want to do is find the cosine, and I can find the cosine once I know the secant, because I know that the cosine and the secant are reciprocals. So if secant is 1 it's negative square root of 5, then cosine is equal to 1 over negative square root of 5. Rationalize this by multiplying by the square root of 5 over the square root of 5. So get the square root of 5 over negative 5. So this one I already get a negative answer for, and that's good. Square root of 5 over 5, and then negative. Alright, the next thing I need to do is now figure out how can I find sine and cosecant now that I know 4 identities. So I want to try to find an identity that has sine in it, and that also has either a cosine, secant, tangent, cotangent. Well, I know that this identity right here, sine squared, is equal to 1 minus the cosine squared. So I'm going to choose to use that one next. I could have used other identities. That's just the one that I chose. I could easily have used this identity, the tangent identity, taken the tangent, plug that in because I know it, plug in the cosine because I know that, and then solve for the sine. But this way I only have to use 2 identities instead of 3. So the sine squared is what I'm trying to find. Really, I'm just trying to find sine. And I can plug in the cosine squared. So if I solve this, sine squared of x is equal to 1 minus, this would be positive 5 in the numerator, this would be a 25 in the denominator, so sine squared x would be equal to 1 minus 5 25ths would be 20 over 25. Take the square root of that, and we get sine of x to be equal to the square root of 20 over 5. And I know that the square root of 20 is the same as square root of 4 times the square root of 5. So it's got to be 2 square roots of 5. So 2 square roots of 5 over 5. And again, I get a positive number here, but I know my answer should be negative. And then finally, to find the cosecant, I can just take the reciprocal. I can use this identity right here. So I'll do 1 over negative 2 square root of 5 over 5. I'll get rid of that by multiplying by the reciprocal, which is just... So now my problem is I've got to get that square root of 5 out of the bottom, so I'll times by the square root of 5 and the square root of 5. So this becomes 5 square roots of 5 over a negative 2 times 5, which would be negative 10, and then I can reduce that by 5, so it would be square root of 5 over negative 2. And again, that answer should be negative as well. Okay, the next example is giving me the sine of negative x is equal to negative 2/3, and the tangent of x is equal to negative 2 square roots of 5 over 5, and I want to find all of these other trig identities here. So right away, I'm noticing something a little bit different. This is actually a reduction formula. So looking at your formula sheet, you have a reduction formula that says that the sine of negative x is the same as the negative sine of x. So I could rewrite this as the negative sine of x equals negative 2/3. So I'm just replacing the sine of negative x with negative sine of x. And algebraically, if I solve this for sine, I would divide by negative 1, and I'd get the sine of x to be equal to positive 2/3. So now I know that the sine is positive. So I'm thinking about where sine is positive. That's where the y values are positive. So sine is positive in these two quadrants. Quadrants 1 and 2. And over here, tangent is negative. And that's occurring in quadrants 2 or 4. So here and here. So now I know I'm in quadrant 2. So if I think about quadrant 2, we just discussed that the tangent is negative, which means that the cotangent is also negative. The sine is positive, which means the cosecant is positive. And in quadrant 2, the cosine, which is the x values, those are positive, so the secant is also positive. Okay, so first thing we've done is we've calculated the reduction formula. Second thing we've done is we have figured out which quadrant we're in. Now, third thing we can do, well, I already know what the tangent is, and I'm going to actually have to erase some of this because I wrote that right there. Actually, what I'll do is I'll just put it over here. The tangent is negative 2 square roots of 5 over 5 is the tangent. So right away, if I know tangent and I know sine, I should be able to find cosecant and cotangent because it's just the reciprocals. So the cosecant would be 3/2. Just flip that upside down. The cotangent would be the reciprocal of the tangent, so 5 over negative 2 square roots of 5. Rationalize 5 square roots of 5 over negative 10. I can divide by 5 and get square root of 5 over negative 2. Again, so far this is good. I know this answer was negative. This one should be positive. This should be positive. Cotangent should be negative. Now I just have to find the cosine and the secant. So we've got a lot of different choices. I know last time when I knew the cosine, I could find the sine by using the Pythagorean identity here. I'm going to choose to do something just a little bit different so you can see it done another way. I'm going to choose to use the tangent identity. So for step 4, I'm going to use the fact that the tangent is equal to the sine over the cosine. And so I'm going to plug that in then. The tangent, negative 2 square roots of 5 over 5, is equal to the sine over the cosine. And so algebraically, if I'm going to solve for this, I'll multiply both sides by the cosine. So now I get negative 2 square roots of 5 over 5 times the cosine equals 2/3. Then to get rid of this, I'll multiply by the reciprocal. So algebraically, when I multiply this, I'd get a 10 in the numerator. I would get negative 6 square roots of 5 in the denominator, and I'd have to rationalize. So I'm going to choose to rationalize before I reduce because then I don't have to reduce twice. So it would be 10 square roots of 5 over, in this case, negative 6 times 5 would make negative 30. Now I can divide by 10, get the square root of 5 over negative 3. And what I'm recognizing right away now is I got a negative answer, and this is telling me that my cosine should be positive. So either I made a mistake here, or I made a mistake here. In quadrant 2, and I'm looking at this now as I look at quadrant 2, that's the x values. X values are positive, or negative, sorry. And then I wrote it down as positive. So that's where I made my mistake. My mistake was that these should have been negative, so sorry about that. That's why it's nice also to put this ahead of time, because if you're getting that, if you're getting the opposite of that answer, especially if you get a negative number and it should be positive, then you know somewhere along the lines you made a mistake. And again, I made mine right there. And then finally, we can take a look at the secant. So step number 5 would be the secant would just be the reciprocal of the cosine, so negative 3 over the square root of 5, and we rationalize. So negative 3 square roots of 5 over 5.